Hi friends. So we're jumping back into the scale factor for these set of notes. What I want to focus on here specifically is the idea of a scale factor. These two polygons must be similar first. So if they're similar, then their scale factor is the ratio of the lengths of the corresponding sides. So it's the ratio of the lengths of the corresponding sides. So just going back very quickly, talking about the ratio from the scale factor. So that means that this is first, order does matter. So because triangle RST is first, that triangle we had was the one with the 5, and then triangle XYZ, that was the one with 3, so it's 5:3. That's one way to write it. Remember, you can also write it as a fraction. If you saw, I actually wrote that above because I wanted to keep that same order. So just know order does matter, and it matters when we're talking about the scale factor with this. So if I wanted to find the scale factor, first we have to see if the polygons are similar. If they're not similar, then there is no scale factor. So if you have a homework problem and it asks to determine this, to find the scale factor, you have to see if they're similar first. If they're not similar, then there is no scale factor. So for this one, we have to see, does each of the triangle angles match up? 1 to 1, 90 degrees, 90 degrees, 2 to 2, 3 to 3. That's good so far. So it actually also gives us the order, so it wants us to find this one to this one. So I need to see if the ratios all reduce down to be the same thing. This is the second figure here, and this is the first one. So all of my numbers that I put in my numerator are going to be from the second one, and then all my numbers from the denominator are going to be from the first one. So here, starting out, z to y is 25, and then f to g is 20. So I have 25 over 20. So I'm going to check to see, is this one going to have the same scale factor as the others? In the teacher notes, they actually wrote out this first, so I think I'm going to do the same. So z to y over f to g, and then y to x over g to h, x to w over h to j, and then w to z over j to f. So again, 20 over f to g, 25 over 20, 25 over 20, seeing if this reduces down to, let's see, y to x, 30 over 24. So I don't know if these are true, so I'm going to put question marks above these. We're going to find out if this is true. And then x to w, so that's 15 over 12. And then w to z, 20, 16. All right, so I'm going to see if all of these reduce down to be the same thing. 25 to 20, 5 goes into both, so that'll reduce down to, let's see, 5/4. 6 goes into both, that's also 5/4. 6 goes into both. Ooh. 5/4. 5 goes into, no, 3 goes into both of those. 5/4. And then 4 goes into both of those, 5/4. Okay, so it does reduce down, does check, so it is, these are. And so then the ratio, the scale factor, is 5 to 4. Again, make sure that you have the order correct. This is looking at the bigger to the small. In this diagram, I'm saying that these two are similar, and so now it says find the scale factor. So because it's similar, I don't need to go through and check each of these. In fact, what I want to do is be really cognizant on which one I want to find. I want to find a set that actually has both the numerator and the denominator matching up. Some of these have variables. Be really careful. This x is lowercase. This y is lowercase. This z is lowercase. Again, be really careful. So what I want to do is I want to match up. So it says w to x, so that's 12, to m to n. So that doesn't work for this one. So let's see, x to y is 8, and then n to o is 10. Ah, perfect. So that actually is the scale factor that I want, because then I have 8 over 10. So now I just check to see if it reduces. It does. So my scale factor is 4 fifths, or 4 to 5. I already found the value of x. We actually just talked about in the previous one, because what I want to do is I want to find out m to n. M to n goes with the first two, so I need to find the set wx, knowing that it's proportional. So we know to find the values of these, I know, let's see, so I know that m to n is x and wx. We're going to do 12 first, so 12. So wx, that's our 12 here, wx over proportional m to n, so that's that x here. And I'm going to set this equal to, and I know from our scale factor, 4 to 5, it's going to be equal to 4 to 5. Now I can just cross multiply. So if I cross multiply, 4x equals 60. So I know that x is equal to 15. So that helps me find x. I'm going to do the same thing now with the others. What I would encourage doing is pause the video now. See if you can finish y and z before we rejoin. See if you can find it. Okay. So now y is, let's see, w to z or z to w. So this is the last and the first. So y over p to m, so that's 10, is equal to 4 fifths. So now I have 5y equals 40, divide by 5, and you get y equals 8. So there's that one. And then z actually is probably the easiest out of all of these, because z actually matches up with the degree measurement here. Angle y and angle o are the same. So angle z is going to have the exact same measurement, so it's congruent to angle o, excuse me. So z value, the value of z, is equal to 135 degrees. Degree symbol is already there, so I can just leave it as 135. Now it wants me to find the perimeter of, looks like the smaller one. So remember perimeter, you add up all the sides. It's going to be 12 plus 8 plus 12 plus, we found y earlier, that was also 8. So 12 plus 8 plus 12 plus 8 gives me 40. And then I just put a label at the end if it doesn't give me one. Perimeter, we always know it's an amount. There needs to be a unit with it. Your science teacher always wants you to put units. So we're going to appease them and be correct. But let's see, this is 15. So I know that this is 15, and then I know that this is also 15. Setting up my proportion, I can find that as well. So then when I find the the perimeter of the larger one, that's 10 plus 15 plus 10 plus 15. So let's see, that's 30, 40, 50. So another way that you can do this, besides what we just talked about, is we know that this ratio of the smaller one is 40 and the ratio of the larger one is 50. That means it's going to reduce down to 4 fifths. So that means I also could have taken 40 over x equals 4 fifths and multiplied this out. That would have given me 200 equals 4x, divide by 4, divide by 4. Oh no, my purple pen. No, purple pen. There we go. And then that gives me x equals 50. That's another way to see it. All right, so for the next part, I wrote really hard. All right, so for the next part, we're going to be talking about the perimeters of similar polygons. It just comes back up with what we just talked about. And we'll actually save that for the next video. So I will see you then. Bye, friends.